In this video, we are going to solve quadratic inequalities. First, we define a quadratic inequality is any inequality that can be written as follows. ax2 plus bx plus c, for example, less than 0. And of course, here we can have bigger than or equal to 0, less than or equal to 0, or bigger than 0. Good. Now, I'm going to define a function, a quadratic function with using the quadratic expression. This is called the quadratic expression. It's a polynomial of degree 2. This is the polynomial. This is the degree, sorry. I'm going also to define the quadratic equation ax2 plus bx plus c equal to 0. If I try to graph the function y equal to ax2 plus bx plus c, among other things, I can go and find the x-intercept. To find the x-intercept, I need to solve this equation. This can be solved by factoring, using the quadratic formulas, extracting the square root, completing the square, and so on. We are going to solve it using the quadratic formula, in which case first you go and you find the discriminant. This is called the discriminant. And depending on the sign of the discriminant, so if this delta here is positive, you will have two real solutions. If delta is negative, you have no real solutions. If delta equal to 0, you will have one real solution. So example number 1, we are going to solve this inequality here. Now, step number 1, let's write it in standard form. If we add plus 2 and plus 2 here, that will simplify to this. So let's define y as minus x2 minus 2x plus 2. And we are looking for the sign for y. We are looking for the values of x when y is positive. This y is a function. I can go and graph it. Before we graph it, let's find the solution, the solution of the quadratic equation. So delta b is minus 2 b squared, b is minus 2 minus 4a minus 1 and c equal to 2, and this gives me 4 plus 8, 12. Find the solution. There are two solutions, remember. They are given by the quadratic formula. b is minus 2 minus b is 2 plus or minus square root of the discriminant delta equal to 12. 2a is equal to minus 1. This can be written as, now square root of 12. Square root of 12 is square root of 4 times 3. Square root of 4 is 2 over negative 2. Now we can factor the 2 in the numerator, simplify the whole thing, which will give plus or minus negative 1 plus or minus square root of 3. Now, if I am graphing y, we know it's a parabola, it's a quadratic function, and we know it's a parabola that goes down because the a is negative, and we know it has a 2x intercept. Now let's give an approximation to the x-intercept. The first one will give 0.73 with the plus, the second one minus 2.73. So if I want to graph the y, it's a parabola going down and going through the x-intercept minus 2.73 and 0.73 and something like this. So between the x-intercept, it's positive, the graph is above the x-axis, therefore the y is positive, and here it is negative. So this is the graphical approach. I can also do this. Put the zeros or the solutions, the smallest one on the left, what do? I go and find test values. For example, this is negative, this is positive. I can go and take 0 here. Here I can take -4. Here I can take +4. Now when I say here, remember I have got 3 intervals. So when I say here, I'm talking about the interval. The first interval is -infinity to the first solution. The second interval from the first to the second solution. The third interval is here. I know that the sign of the y, which is the graph, changes at these zeros, and that's why I'm using them. Now these are test values. How can they help me? They can help me by just checking the sign that I found in the graph. Or if you don't want to use the graph, altogether, this is how you proceed. So you go and you calculate y when x equal to -4. So when x equal to -4, you go and you calculate your y here. That will give you -16 plus 8 plus 2. That will give you -6. And so you put the sign of the y here. So because of this, x equal -4 gives me -6. My y will be negative on all this interval. 0. Put the 0 on the y. 0, 0 plus 2, positive. All your y will be positive. And here, if you put +4 into the y, that will give you -16, -8. That will be negative, definitely negative. And you put, so this is the sign of y, which exactly corresponds to what we found graphically. So it's up to you. You can think about it graphically or using the table of sign and the test values. Here I just complete x equal to 0, y equal to 2, so it's positive, and then x equal to +4, that gave us y that was negative as well. So now, so let's put this together. Yeah, first you put your zeros on the number line with the smallest one on the left, select test values, find the value of y with these values. They will give you the sign, and then you put them here, and that's it. You have the solution. Graphically, you put the x-intercept and you look for the values when the graph is over the x-axis or below the x-axis. Good. Now let's put all these together now and write our solution using interval form. So the solution set -1 minus -1 minus square 3, comma, -1 plus square root of 3. This is the solution set because we are looking for y positive, this positive, and this is where it's positive between here and here. So it's up to you. You have got two approaches: algebraic using test values, or graphical, or both. To check one we check the other. Second example, we are going to solve the inequality, and this case will cover when the delta, the discriminant, is less than 0. It's a negative. So 3x2 minus x plus 3 less than 0, rewriting the inequality in standard form with 0 on one side. go and find the discriminant. B is equal to -1 minus 4ac, and this is clearly negative. It's going to be negative. It's negative 35. So what do we do here? Now let's look at this graphically before we move on. Now remember, graphically I look at this function here, which is a parabola. It has a, the leading coefficient, positive, so it's a parabola that goes up but doesn't cut the x-axis. That's one way to do it. Now, hang on, this is not quite a parabola, so let's put it like this. So again, it's a parabola going up and doesn't cut the x-axis, and therefore it's always positive. We want something negative, so no solutions. No solutions. How do I do this algebraically? Algebraically, it's very simple. I take one test value, for example 0, because it's easy to do. I substitute x equal to 0 into this expression, which I call y, and then when you put 0 here, 0, 0, 3, it's a plus 3. Plus 3 is not negative, so no solution again. Again, you have got two ways to look at this problem, either graphically or algebraically using the test value. Third example, we're looking at an inequality where when we go and find the discriminant delta, it will be 0. Now, so let's find the delta equal b squared. So we need to solve this inequality. B squared, b equal -4 squared. Minus 4a, a is equal to 4, c equal to 1. 4a, c equal to 1. And this gives me 16 minus 16, 0. Now, this will give me one solution. Remember, x equal minus b over 2a. Where does this come from? Because remember, the general solution is plus or minus square root of delta, but this is negative. This is equal to 0, so it goes. Now, let's find the solution. B is minus 4 minus b give me 4. 2a, a is equal to 4. So that gives me 1/2. Now again, let's look at it graphically and algebraically. Now, graphically, what does it mean? It means that at x equal 1/2, the graph touches, remember it's one solution, touches the x-axis. Now the parabola goes up. The parabola goes up. Oh, no, this is not a parabola. This looks like a parabola. It's going up. And we can see that it's positive everywhere except when x equal to 1/2. So when x equal to 1/2, y is equal to 0. Now let's look at our inequality. What do we want? We want strictly positive. So the solution set is going to be using interval form from -infinity to 1/2, union 1/2 to plus infinity. This is the solution set. Now, algebraically, how would we do this? We do this as follows. First, we write the solution that we found. We go for test value. Any value except x equal 1/2. So let's take x equal to 0. It's easy. Find y. Where is y? Y is all this. Remember, is the quadratic equation 0. 0 plus 1. It gives me 1. 1 is positive. It satisfies the inequality. So my inequality is satisfied for all values of x except x equal 1/2 when it makes y equal to 0, and I don't want it. Again, -infinity to 1/2 union 1/2 to plus infinity. Now, as a conclusion, we try to look at these problems of quadratic functions or quadratic inequalities using both algebra and the graph. I would use both of them because one will check the other. That's one way. Second thing, you don't need to factor because sometimes it's not easy to factor, especially when you have got irrational zeros. So this method will take you through any kind of quadratic inequalities. Even if you cannot factor it, you just go and find your solutions and then set up the tables or the test values and then find the solutions.